Hey, what's up everyone? Welcome to this new chapter of my training course to learn SwiftUI when you already know UIKit. In the previous chapter, we did a bit, we could say, of theoretical work because we saw how to implement implicit data flows between views, and this time the content is going to be much more practical because we're getting to what is, I guess, from the reaction I saw when I announced the live for this new chapter, one of the most anticipated of the training course because it's the chapter where we're going to see how you can mix SwiftUI views and UIKit views together. And you'll see that this chapter might be surprisingly short because the SwiftUI team really did a great job, and you'll see that the mechanisms to integrate the two frameworks together are quite well made, and honestly there isn't that much to say about them besides explain how they work, but there are not that many hidden tricks, we could say. So what are we going to see in this chapter? We'll see first how to integrate a UIKit view or view controller in a SwiftUI view. And this can be really useful when you need to use a component that isn't available yet in SwiftUI. And then we'll see how to integrate SwiftUI views inside UIKit context. We can use them either as UI view controllers, or as we're going to see, and this is a more recent edition of SwiftUI, we can also use them in table view cells and collection view cells. Before we get started, so if you're watching the replay, you've got a link in the description to get access to the code. If you are watching live, please remember that the big advantage of watching live is that you can ask comments and questions in the chat. I will do my best to answer them, but your comments and your question will be invaluable for the people who watch the replay, because it's very likely that if you had this question or that remark, the people watching the replay will also have the same, and so by voicing it, you give me a chance to answer it for everyone. And finally, if you enjoy this training course, you will find a link also in the description to buy it on Gumroad. So you will get the same content than what's available on YouTube, except you will have a button to easily download all the videos and all of the projects. But if you want this convenience, you can buy it. If you enjoy the course and you just want to leave me a tip, you can also buy it. It's available from $1, but you can name the price that you want. And I think it's all I need to say for this intro, so let's actually get started. I see a few people in the chat. Welcome everyone. I see that some people are looking forward to this chapter. Yes, I know that this is usually one of the most anticipated chapters, and you will see that most of the things we've learned before will somehow come into play, and so you will also understand why I have put this chapter more towards the end of the SwiftUI course. Because yes, I need to tell you, if you're watching live, we're getting near the end of the course. This is not the final chapter, but it might be the penultimate chapter. Enough said for the intro, let's get started. So I'm going to create a project from scratch. This way you can follow easily if you are watching at home. So we create a new project and we'll start by how to embed UIKit in SwiftUI. So I will name it UIKit _in _SwiftUI. Like that. Maybe it will look better with a lowercase I. All right, so interface SwiftUI, of course. Then we create the project. I put it wherever. I will put it on my desktop. Okay, so we have our new project. The warning was just about me not having or put my email address for the Git client in Xcode, something that we can absolutely dismiss. And so, what UIKit view are we going to embed in SwiftUI? We're going to embed a view that is actually a view that most iOS developers don't like that much, but I guess we can all agree that it is a necessary evil. I'm talking about web views. We are usually not a big fan of putting web views in our apps because we would much rather implement the features that they provide for a web page as a native feature. But still, after something like a bit more than 10 years of experience doing iOS, I don't think I have ever encountered a real-world app that didn't use a web view at some point, even for like trivial things like showing terms and conditions, showing a legal boilerplate, that kind of thing. At some point or another, you need to use a web view in your app. And as it turns out, there is no built-in web view in SwiftUI. So if you want to display a web view in SwiftUI, you need to wrap the existing web view in UIKit. So we won't be using UI web view because that one has been long deprecated. We will be using WK web view, which is part actually of WebKit, if I remember it correctly. So not exactly UIKit, but it still uses the UIKit view hierarchy. I see a few messages in the chat, so let me see. I see a question. Anyone got a good how-to on how to do iOS, iPadOS, Apple TV, and macOS in the same project using different schemes? Good point. I will take just a few seconds to answer it because I know it's a topic that I don't cover in my training course. But if you're just looking for the basics, some of the tutorials Apple has made about SwiftUI cover this, and they give you only the basics. They don't talk about like architecture at scale, but still, when I saw it, I was pretty pleased with what they had done. So I would recommend that you go check out these tutorials, and you can type on Google, I guess, Apple SwiftUI tutorial. They shouldn't be like too hard to find. Actually, I think I have a few live streams on my channel from 1 or 2 years ago where I did a few of these tutorials live. So you can go check this out, and hopefully it should not answer all the questions, but give you the basics so that you can then know where to look further. As always, I have my script next to me so I can make sure that I don't forget to tell you anything. So when you see me looking at the side, that's what I'm looking at. Okay, so we are going to embed this view inside our SwiftUI app. So I'm going to get rid of the preview right now because we don't need it. And I'm going to create a new file. So I'm going to go right here. I'm going to create a Swift file for now, and I'm going to call it web view. Okay. Then inside this file, I'm going to create a struct that will represent my web view in the SwiftUI world. So it's going to be a struct because in SwiftUI, remember, views are structs because they are actually descriptions of the view that will be shown on the screen. And actually, if you had a bit of struggle understanding what was the difference between the description of the view and the actual view, this chapter might help you get a better grasp on how this works, because we are actually going to implement part of that life cycle between the description of the view, of the web view that we will be using in SwiftUI, and the actual web view that we will need to instantiate and configure in our code. So this struct is called web view, and I need to state that this struct wraps a UIKit view. And for this, I'm going to implement a protocol. So this protocol is part of SwiftUI, and it's called UI view representable. And you can see that it's a wrapper for a UIKit view that you use to integrate that view into your SwiftUI view hierarchy. So exactly what we need. Before I click to use that one, you can see that below we have another protocol called UI view controller representable. It's basically the same thing, except that it lets you, so it's funny because the description is less good for that one, but it's basically the same description. And for the first one, it's a wrapper for a UIKit view controller so that you can use it in a SwiftUI view hierarchy. Why are there two types? It's because UI views and UI view controllers in UIKit have different life cycles, and so there needs to be two different protocols to manage these two life cycles differently. In this chapter, we will see how to embed a view, a UI view, using UI view representable, but the logic is essentially the same for a UI view controller, and actually it can be a nice exercise if you want to check that you have indeed understood everything, to try and embed one of UIKit's built-in view controllers inside SwiftUI. So you can do that as an exercise. So you can see that we get an error that says type WebView does not conform to protocol UIView representable. That makes sense. So let's start and see what we need to implement to conform to this protocol. And you can see the first thing is to provide through a type alias the actual UIView type that we are wrapping. So the UIView that we are wrapping. So in order to be able to provide it, I need to import WebKit because, as I've told you, WK WebView lives in the WebKit framework. And now I can say that this is WK WebView, the type that WebView is wrapping. We get another error because now there are other methods we need to implement, but these methods, they needed to know, the compiler needed to know which was the UI view type to be able to infer the signature. Actually, since we have the type, the UI view type stated through the return type here and through the argument, the first argument of the second method, we can get rid of this type alias. Now it's become redundant. We don't need it anymore. And so we can see that we have two methods. One method called make UI view from a context. It will return an instance of WK WebView, and then update UI view with that same UI view passed as an argument and that context also passed as an argument. So we're going to start by implementing the method that will be called the first in the life cycle of our web view, which is make UI view. I'm just checking I haven't forgotten to tell you anything. Okay, so what do we need to do to implement this method? We need to return a WK WebView. So we can instantiate one and return it. And actually, that's it. We have implemented the method. We don't need to do anything more. And for update UI view, for now, we are not going to put anything inside because, of course, this is where we will want to load the request that the request for the web page that the web view will display. But for now, we don't have a way to get this request. So for now, we do nothing. First thing I want to show you is the fact that the method makeUIView returns the WK WebView, but you can notice that I don't store it anywhere inside my struct. And this is extremely important because it is really the beginner's mistake or the rookie mistake to do something like this, to do like that, so to create a property on my struct WebView, which is an optional WK WebView, and inside makeUIView to say, okay, well, I'm going to set my property and then return the value of my property. This code is going to work because we are still returning. So we have an issue with the fact that that we are not inside the mutating method on a struct, but we could find ways around it. But the big issue here is that we are not supposed to store the view. That's the point I want to drive. These two methods have been designed specifically so that we don't have to store the view, because with the first method we build the view, and for the second method where we update the view, we are passed the view as an argument. So we don't need to store the view ourselves. It's actually the job of SwiftUI to manage the instance that we return, to manage its life cycle, to make sure that someone is keeping a reference, a strong reference to it as long as it is needed. But we especially don't want to store a reference to the view. If we do so, the code will work, but we will be creating what is in a way close to a retain cycle, because we will be storing things that don't need to be stored. And so if at some point SwiftUI releases the view, for instance, maybe our struct will still retain it and the view won't actually be released from memory. I see a few messages in the chat, so let me see. I see a question. Do you know when it will be possible to get the selected range in a text editor? Because right now it's necessary to use UI text view or another UIKit view that supports that. So I am not sure like what's the current status on this exact point, but the question raises something very interesting, which is that it's true that some of the widgets that we use in SwiftUI, like text fields or text view, they don't always offer the same level of control than what their UIKit counterpart does, and in that kind of situation, then you often end up having to use UIKit. It can happen, and it happened to me a few times, that you start using the SwiftUI component and everything works well, up until the point where you need to use a specific feature, and then you have to like backpedal and change to use the UIKit version using this protocol UI view representable. The good thing still though is that since there are only so many UIKit components, UIKit views, most of the time you can already find wrappers that have already been made for you, so you don't need to implement the wrapper yourself. But still, it's a bit frustrating. So thank you for raising that point. Okay, so I see a few questions and comments regarding the topic of how to manage the several targets. So for these questions, I'm sorry, I'm not going to answer them for a first very good reason, which is that I'm not that much of an expert on the topic. I haven't used it that much, not to say almost never outside of tutorials, and yeah, basically I don't have a way to give an answer that is relevant. But if someone is watching live and wants to share like their knowledge in the chat, please feel free to do so. Okay, I'm checking. What do I need to show you? I want to show you a web view that works. So right now, if we were to use our web view in a SwiftUI view hierarchy, it wouldn't work because we still need a way to provide the actual URL of the web page. So to do it, it's relatively straightforward. This URL is something that we should pass through the init of our web view. So we can declare it as a let constant for now. We'll see if we need to make it a var some point later. I see in the finished project that I have under my eyes, it's actually a var, but I'm not sure if there is a reason why. So I will start with a let, and we'll see if at some point I need to switch it to a var. So we have this property here. And so now we can implement update UI view, and in update UI view, we can take the UI view we get as an argument, and actually I'm going to rename it web view rather than UI view because it's much more correct that way. And you can always rename the internal name of an argument. It doesn't change the conformance of the fact that you conform to the protocol. And so I'm gonna do web view dot load, and I need my URL request, and I'm going to build it using the URL that I have stored in my property. Let's see whether this code builds. I think I also need to import foundation, maybe, that I have removed. Oh, it's URL request, of course. Okay, so this code does build. You can notice that I'm doing the load in update UI view and not make UI view. And I want to show you the docs to see maybe it's explained inside the docs. Let's see. What do they say in update UI view? So updates the state of the specified view with new information from SwiftUI. So when the state of your app changes, SwiftUI updates, all right. Use this method to update the configuration of your view, okay. And here you must implement to create your view. Okay. It doesn't state exactly what I wanted to say, but basically my logic is that this action of starting a network call is costly, and so I want to make sure that it only happens when it is actually needed, and that's why I put it in update UI view, thinking that there are probably instances where make UI view could be called earlier than update UI view, and so I don't want to start this costly work when it's not needed. I think we'll try to put some breakpoints in these two methods to actually see when they are called, because it can always be quite interesting to see that. Okay, let's go back to our content view and actually use our web view. So I'm going to remove the vstack and replace it by my web view. I need to give it an argument which is the URL. So I'm going to build it from a string in order to stay simple. And let's say that we are going to display Apple's website, for instance. So something like that. I'm gonna force unwrap it. Okay. Let's see what happens in the preview. So for now, nothing appears, but with the preview, you never know if it's a mistake or not. I mean, if it's a mistake on Xcode's end. So let's see. I'm also booting up the simulator to see what happens inside the simulator. It's possible that I've simply like forgotten to implement something at some point, but previews behave slightly differently when it comes to web views. So let's see. Okay, so we have our web view right here, but nothing is happening to actually load the URL request. So that's interesting. So let's actually put some breakpoints and see whether the two methods are called or not. So I'm relaunching the app in the simulator, so we can see that here WK web view is indeed. Oh, I forgot the HTTPS. Oh, thank you, good catch. It's always the small typo that gets me, but at least it pushed me to put the breakpoints, which is interesting because we can see that it seems that make UI view is called during the startup of the app. So it's called, maybe it could be called maybe even before the view gets actually displayed. So doing the separation of like the loading the request outside of make UI view was indeed the right call. And so if I resume, now we can see that update UI view is also being called. Okay, let's remove the breakpoints and let's see. I think I might need to rebuild the app because yes, okay. So it's working perfectly in the simulator, and if I go in the preview, it's working also in the preview. And what I wanted to show you, and it's something that changed in the last version of Xcode, because now by default you have the live preview being displayed, and in the live preview the web view is displayed perfectly well. But if I go to this version, which is so it's called the selectable preview, but it's the one that is static, we could say. In that one, nothing is displayed, and that's because when your SwiftUI view wraps is actually a UIKit view under the hood, it will not appear most of the time in the selectable state, because the work that needs to be done to initialize the view might not be run. Just like it's the case here, what's probably happening is that the network call is either not started, or Xcode doesn't wait for it to return before it renders the preview. So remember, when you want to use previews with UIKit view or view controller that is put in a SwiftUI view hierarchy, make sure you use the live preview, otherwise your view might not be displayed. So we've been able to embed our first UIKit view in a SwiftUI view hierarchy. So first thing is that I think I didn't lie when I said that the mechanism was quite straightforward, because as you can see, all we needed to do was write this code. So like barely like 11 lines of code, so pretty simple and straightforward. So that's a good thing, because it shows that when you need to revert, revert is a bit like negative, but when you need to use UIKit in SwiftUI, it's not, that big of a difficulty. Like you're not going like you're not like oh, I need to go like down that road, which is like super annoying. It's been pretty well made. But of course, we've only scratched the surface, because imagine, for instance, if you were to put a text field in a UI text field in a SwiftUI view. Yes, you want to display the UI text field, but probably you also want to react to the delegate events, for instance. So how do we deal with that? How do we implement the delegate of a UIKit view when that view has been embedded in a SwiftUI view hierarchy. This is what we're going to see right now by implementing one of the delegates of WK Web View. But first, let me check that I haven't forgotten anything. No, I've said everything I needed. Okay, so now the goal is to implement a delegate of WK Web View. So let me switch on my other screen the finished version of the code. Yes. So we're going to implement a specific delegate of WK Web View. I say specific because WK Web View is quite a complex view. Displaying web pages is a complex job. Web browsers are complex pieces of software. And so there is actually two delegates in WK Web View. I say two, but there might be even more. I just see these two, but there might be more that I am not thinking about right now. We have the navigation delegate and the UI delegate. We're going to focus on the navigation delegate because it's the one that is called to know what should happen, for instance, when the user taps on a link. When the user taps on a link, so when the user performs what's called here a navigation action, what should be the navigation action policy, which is a way to say, should the link be open or should it be ignored, that kind of thing. So let's see how we can implement this delegate. So first thing, I'm going to put my web view in a local variable. This way I will be able to set the delegate property on it. So I return the web view, okay? And on the web view, I want to implement the navigation delegate. What could play the job of the delegate? And this is where a nice piece of software, a nice design pattern was implemented by SwiftUI, because SwiftUI has a built-in mechanism to implement these delegates or data sources, and it's to use an object called a coordinator. So how does it look like? Most of the time it's going to be an object that you declare as an internal class of your struct. I don't think that there is actually a requirement for it to be an internal class, but by doing it, you scope it, and it just makes sense because this coordinator doesn't make sense outside of this struct web view. So we create this class. You notice it's not a struct, it's a class, because this delegate will be an instance that will be kept alive in order to react to events sent by the web view, which is also an instance, and which is also a reference type, and so has instances. And so my coordinator, I will need to make it conform to NS object because it's interacting with UIKit objects that also expect this conformance. And I'm going to make it conform to the protocol I want to implement. So here it's WK navigation delegate. All right, let me check a bit the chat. Good question. Do you really need to import Foundation when there is already importing SwiftUI or UIKit? Honestly, I think not. I will try and remove it at some point, but I think it's not needed here. It's possible that they import it on their own, yes. Oh, I put an unbreakable white space. Okay. So here I'm going to implement my delegate method. So it's going to be, let's see, it's web view decide policy, and I'm going to use the version with the completion handler in that case, just to keep things simple, and it's this one. So be careful if you're following along, because there is another method with a decide policy for, but a different type here. I think it's WK navigation response. You don't want to use that one. You want to use WK navigation action. Let me format the code so that we can see a little bit better. All right. So here is the method. Now, what can we do? First thing we could do is just return a hard-coded value. For instance, we could call the decision handler. So the way that we that we pass our action policy, navigation action policy back to the web view and say, okay, we want to cancel, so we don't want to allow navigation. When the user taps on a click, we can't, we just want to disallow that, so the UI will show that a click has happened, but there won't be any navigation to a new page happening. I see a question. So Martin, you're asking, why can't the web view struct conform to navigation delegate? That's because the navigation delegate right here, let's see what it looks like. So we need to have a navigation delegate. You can see it's marked as weak, so it's really meant to store an instance. And if we were to make the struct conform to navigation delegate, it would probably not work and not even build. I'm sure it won't work, but I'm sure it won't even build. I will try it when this code builds, just to show you, because there might be some learnings from it. But anyway, it's also a great question, so thanks for asking it. Okay, so we have a simple version of the delegate implemented. Now the question is, how do we set the delegate? And what's really kind of magical is that we'll be able to get the coordinator through the context right here. So you can see that there is a coordinator available here inside the context. So it's representable.coordinator, so another type alias of UI view representable, if I'm correct. Let me see. Yes, we have this other type alias coordinator. By default, it's void, because this way it allows you, if you don't want to use the coordinator, to have your code still build, and void is a type that does nothing. But what we can do is implement the function make coordinator. So be careful, this function, this method is part of the protocol UI view representable, so you want to implement it at the level of the web view and not inside the coordinator. And what do we do here? We just create and return the coordinator, and for now, since it has no argument, we just call the init with no argument. You can notice it's the same logic than make UI view. We instantiate and return the value, but we don't store it anywhere in the struct. Once again, it's SwiftUI's responsibility to store the coordinator as long as it's needed, just like it was already its responsibility to store the WK web view. And if I try to build this code will build, and you can notice something interesting, which is that I didn't need to do any cast in order I didn't need to do something like this, you see, which we might have expected, because coordinator seems like a very generic object, but it's not needed, because coordinator is not represented with something like any object. It's actually a generic. We saw that it was using a type alias, and so coordinator is of the type, is this coordinator right here on the context is strongly typed to the return value of the method make coordinator. And so this way the compiler can check that we are indeed using a coordinator that does conform to WK navigation delegate. And I think this is really cool, because it's not too complicated to use this generic feature. It basically comes to you for free, because it uses the information that's encoded in the return type of the method make coordinator. And it's a great feature, because if by mistake we had forgotten to make our coordinator conform to the protocol, we would have gotten an error. So I would like to see the error appear. Yes, now it's appearing. That says you cannot assign value of type the web view coordinator, so this thing right here, this class right here, because it doesn't conform, it doesn't conform to WK navigation delegate. So that's great that the compiler is able to check this for us. And so there was a question in the chat: what happens if we make the struct conform to the protocol? So I'm going to remove this coordinator thingy and instead say self like this. And we have a build fail. I want to see the error. And so it says non-class type WebView, because WebView is a struct, cannot conform to class protocol WK navigation delegate, because this protocol is only usable by a class, which makes sense because we are in the UIKit world, we are in the object-oriented world, and so it expects instances. And so it was a good question, why can't we use the struct to be the delegate? That's this reason we need to have an instance, because that's just how UIKit expects things to work, and that's why we have this coordinator system in the bridging between SwiftUI and UIKit. And so thanks again for having asked that question, because it allows me to go on a bit more about what are the motivations for this coordinator. Why do we need this coordinator? This coordinator is just because we don't create it just for the sake of it. We create it because it solves an issue, the issue that we've just seen. Okay, so right now, I think if I go back to my content view, in my preview, so I'm going to make my preview pinned. This way I can display my web view. Okay. So nothing is being displayed, but that could be because since I have said cancel for everything, yes, I have said cancel to everything, including the initial load, which is not what I wanted, of course, but it allowed us to show that still it worked because the view wasn't loading. Of course, I don't want that. I would like to be able to get better control over what is happening right here, because probably I will have more than one web view inside my my app, and so there is no one size fits all. Solution. Each view that uses my web view needs to be able to give its own behavior for what should happen when a link is tabbed inside the web view. All that to say that we need a way to implement a data flow between our content view that uses our web view and the WK web view inside. We need to be able here in this code to define what should happen when a navigation action happens inside the web view. So how are we going to do it? It's going to be once again, and you will see that it's definitely the theme for this chapter, quite straightforward, because when you start to put the problem into words, basically you just need to implement what you are thinking about, and it's just the way it's supposed to be done. So what do we need? We need a way to have a function that takes a navigation action as an argument, and that returns a navigation action policy. Okay, where should we store it? We should store it inside our web view, because this is where we have already stored the URL. So let's introduce a closure. This closure will be called navigation policy, and so it will take as an argument a WK navigation action, that one, and return a WK navigation action policy. And we can now use this closure inside our delegate method, or rather we would like to, but we are missing something because we have defined the closure on the web view, and we need to use it inside the coordinator. And so what's the trick here? It's the only part where it feels a little bit like a trick that if you don't know it, it's not as straightforward as the rest. But the pattern that you use here is that you put a var so a property in the coordinator for the parent. So that's where you will have a link to the struct. And what you do is that when you create the coordinator, you pass it, the struct passes itself as an argument to the coordinator. So we need to define an init, because the coordinator is a class, and so it doesn't get an init for free synthesized by the compiler. But now that the coordinator knows about the web view, about the struct, we can use the parent, we can call the closure. So the closure is a navigation policy, and we call it passing the navigation action as its argument. So like that. We just have one issue here. Yes, I'm going to ignore the name of the argument. So this file builds, so now we have the mechanism in place. So when the delegate method is called on the web view, the coordinator is called, and it looks at the closure that's stored in the parent to know what navigation policy to take in response to this navigation action, and it passes that information back to the web view. The only question left is how do we set this navigation policy? Right now, since it's declared as a let constant in the web view, just like the URL actually, we should provide it just like we did with the URL, so by passing it as an argument through the init. This would work, but I would say that it's not the best approach here because, as you can see, it takes like quite a bit of place passing a closure in code. It's a big syntax, and it might not be the only closure we need to pass. If we need to implement all of the delegate method, we will need to pass a closure for each of the delegate method, and adding numerous closures to the initializer of a view is definitely not something that scales, or at least when you say it out loud like that, it doesn't feel like something that scales, and so there is actually a better approach for it. But I wanted to show this approach because it's a question that is quite legitimate, and it's possible that when you will be writing your first SwiftUI code, at some point you will be wondering when should I provide an argument through an init, so like we are doing right here, and when should I provide an argument through a modifier that I call on the view, like we're going to implement just after. And I would say in the init, you should only pass the arguments that are absolutely essential for the view to work. A great example for this is vstack and hstack. Their init takes 3 arguments: the alignment, the spacing, and the content. 2 of them actually have default values, but the 3 of them, it wouldn't make sense to provide them through modifiers because the content is the content that the view displays, its entire purpose, so it makes sense to pass it through the init. The spacing also, because the spacing and the alignment for a view that is meant to group other things together, if you don't have these 2 information, the view cannot do its job. And so it makes sense to pass them to the init because first it conveys how important they are, and also when they are passed to the init, you can guarantee the fact that a value will be provided once and only once, so exactly once. Whereas when you provide the value of an argument through a modifier, like we're going to do in a minute for our closure, you have no way to guard against a user calling the modifier more than once. And of course, most of the time only the latest value will be used, but still it might degrade the quality of the code. So that's the insight I wanted to share, that in the initializer of the view, you should put the argument that makes absolute sense for the view to work. If these arguments are not provided, the view should not be able to work correctly. So here, for instance, for a web view, if we don't have the URL of the web page that we want to display, basically the web view won't be of much use. So it makes sense to have this argument passed through the init. However, for the navigation policy, it makes better sense to set it through a modifier. And how can we implement this? It's quite easy. First thing is we need to turn the let into a var because the value will be set after the initialization has been done, so it can no longer be a let constant. Then we need to also make the closure optional because someone might not provide a value. The modifier might never be called. You have no way of the compiler guaranteeing that the compiler. You have no way for the compiler to guarantee that the modifier will be called, and actually it might make sense for the user to never set this closure, just like it makes sense to never implement a delegate method that you don't want to use. So we put nil as the default value. Of course, now that it's nil, we need to provide a default value here in our delegate method. So first, the closure can be nil, so we need to call it with a question mark. And for the default value, we'll say, well, we're going to allow by default, which makes sense in the context of WK Web View, because it was already the case when you don't provide any other navigation action policy. And finally, we need a way to set the closure. And so for this, I'm going to create an extension on my web view, and I'm going to implement a method that I'm going to call on navigation. Actually, on navigation is the name that I had put in the finished version of the project, but I'm wondering if this name is as good as possible, maybe as good as it could be. Maybe something like set navigation policy would be better. Let me finish writing this. So I have as an argument the navigation policy. Yeah, I think like set and then navigation policy is actually a much better name. So set navigation policy. Let me get the type of the closure right here. So I paste the type of the closure. I mark it as @escaping because this closure is escaping in that context. I'm going to return a web view. And what I'm going to do is we're going to use the same mechanism, the same pattern that we had used when we had already implemented custom methods on SwiftUI views, which is that we make a copy of the view. On that copy, we set the closure, so the navigation policy, and finally, we return the copy. Be careful when you implement such a method, because it's just so easy to put self right here in the return value, or to put self right here where you assign the argument. And when you do so, the compiler won't catch. Okay, it catches that mistake right there. So this one I was wrong, but the one where you return self, it's quite easy to make that mistake. The compiler doesn't catch it because the code is still valid, but your code has basically done nothing because it has set a property on a local variable that will never exit the scope of your method. So be careful about that one. It's one of the easy pitfalls of this pattern. And so now I can go back to my content view. I'm going to remove the changes. Okay. And so now on my web view, I can, if I want, call the modifier set navigation policy and provide a navigation policy, and to say, okay, when I get a navigation action, what policy do I want to implement? And so here I'm gonna say, all right, when my navigation action is that a link, so it's the navigation type actually. When the navigation type of my navigation action is that a link has been activated, I'm going to disallow the navigation, so say cancel. Otherwise, I'm going to allow it. Remember that if we just return cancel all the time, it even cancels the initial load, and so that's why I'm saying, okay, I only want to cancel when the link has been activated. And it's a question mark here and not a colon. Okay, let's get our preview back. So first, I'm going to comment out this line just to show you that for now, you see, everything is working. If you want to navigate and maybe go buy a MacBook Air, everything is working perfectly. We can navigate. But if I uncomment the code, now you can see that when I click on a link, nothing happens. Interestingly, you can see that the menu still works. That's probably because the menu, actually that's not probably, it's for sure that the menu is implemented in JavaScript inside the web page, but it doesn't trigger moving to another page. That's why the menu still works. But when we click on actual links, so it's interesting. You see these links here, they don't generate a navigation, but what was super interesting was that the first link here, learn more, still allowed a navigation. I guess because it's not probably not like an A tag, and it's mostly some kind of JavaScript code that is called. That might be the reason why. Actually, I will put a breakpoint just to see what's happening when we tap on this thing. Yeah, it doesn't even call like the handler, so it must happen entirely like in JavaScript right here. And on the other hand, when I tap here on this link, oh yes, but breakpoints are not triggered. Breakpoints are not triggered from the previews. That's why the breakpoint wasn't being triggered. Sorry for that. Sorry for the confusion. So let's see. Our breakpoint has been triggered once. It's because remember that the initial load would trigger like the delegate method. So if we look at the navigation action, I would like to see what is the navigation type. So I'm going to go into the console right here. I want to make sure that you can see it also. Okay, I do a PO of this. So yes, it's navigation type. It's not clear like which one it is. If I do something like that, okay, we can see at least it's not link activated. I'm going to resume. Probably other calls are happening. So now when I click to the actual link, this time it's indeed a link activated. And so we say that we don't want to navigate. That's why nothing happens. And if I click on this learn more, so something happens, but you can see that. That's so weird. It says link activated true, all right. So it returns cancel. Oh wait, there is another call. What does the other call say? Okay, this one says false. So there is some like some JavaScript things like happening like under the hood. So it doesn't work in all instances. Anyway, the goal here was not really to show you like how to disallow the navigation in a web view in a reliable and sturdy manner, but it was much more to show you how to implement the delegate of a UIKit view and how to interact with this delegate through the SwiftUI view hierarchy. So what have we seen? We saw that this is done through the coordinator. The coordinator is what implements the delegate. We get access to the coordinator through the context that is passed as an argument to the method makeUIView. So using the context, we set the delegate. SwiftUI takes care of managing the instance of the UI view and of the coordinator. The delegate method gets called when needed, and in order to say in our SwiftUI hierarchy what should happen when the delegate method is called, we have several options, but the one I chose to show you is to implement a closure inside our struct, so the struct that wraps the UIKit view. Here it was a closure, but if it were just like a value to return, it could have been just a value also. And then we need to provide that closure or that value through the SwiftUI view hierarchy. And so we can do it in two ways, either by an argument that we add to the initializer. It can make sense in some cases when it is something that is really important to what the view does, but when it's not the case or when it's something that is optional and might actually never be set and still be valid code, then you can create custom modifiers like the one I've created. And so here I have set the closure that will make the link between the SwiftUI view hierarchy right here and the delegate method of my UIKit object right there. And we saw that besides the fact that we had this coordinator to implement, the mechanism was still like rather straightforward. And I'm sure that now that you've seen this, you can picture in your head like how you could wrap a UI table view, a UI collection view, a UI text field, basically any kind of view that you would need to use in a SwiftUI context, because you don't have an equivalent in SwiftUI. This can also be useful if you need to embed a third-party framework that doesn't support SwiftUI and your app is in SwiftUI. You can wrap its views using this protocol. Finally, I said it at the beginning, but I want to mention it again now that we are getting near the end of this first part of the chapter. I covered UI view representable, which allows us to embed UI views in a SwiftUI view hierarchy, but you also have the protocol UI view controller representable, which you can use when you want to embed a UI view controller in a SwiftUI view hierarchy. These two protocols are essentially the same. They follow the same logic. It's just that because the lifecycle of a UI view is different from that of a UI view controller, SwiftUI needs to have different mechanisms, but the logic is the same. So actually, if you want an exercise to carry out after watching this chapter, you can try and wrap a UI view controller, one of the subclasses of UI view controller, inside your UIKit, your SwiftUI app, and it should not be that hard. A good example would be, for instance, to try and wrap UI. I can give you two examples. You can either try to wrap UI activity controller, the one that allows you to share content to other apps, because until iOS 16 you don't have a native version of it, so it's very possible that you might need to implement this at some point. Or another one is the photo picker, to be able to get a picture from the camera roll of the user. I don't, even in iOS 16, I'm not sure if there is a native picker for that, but you can try and wrap the native camera picker and see how it goes. And since this is a need that is very common, you can just do a Google search and find other implementation to compare and see like if you've implemented it in a way that other people agree on. Okay, let me check the chat. So I see a few people are enjoying. So Landon, Ignacio, you are enjoying the explanation. So thank you. Glad to see that you enjoyed this chapter. Usually, like I think it's one of the more like satisfactory chapter, because it has this feeling of like everything we've seen together is coming into place, and to allow us to do things that feel very actionable, like embedding UIKit views in SwiftUI hierarchies. So we've seen the first half of this chapter, and it's great. It's been 1 hour, so I try to make this chapter like around 2 hours, so I feel like we are perfectly on time, and we can move on to the second part of this chapter, which is how to embed this time SwiftUI views inside UIKit context, UIKit view hierarchies. But before I do, I just want to check my script to make sure I haven't forgotten to tell you anything. All right. Yeah, I think I've told you everything I wanted to tell you. So we are going to actually create a new project in Xcode. So we are creating a new project, just making sure I display it, yes, so that you can see everything in the video feed. So we create a new project, and this time we call it SwiftUI in UIKit. And be careful here, we're going to switch the interface to storyboard, which basically means UIKit, because it will be just much easier if Xcode takes care of writing all of the boilerplate that you need to write to have a base UIKit app. So I'm putting it on my desktop once again. If you've been quick enough, or if you do a freeze frame, you might have seen the thumbnails of my future videos, actually. So if you want to spoil yourself, you can try on the replay to do a freeze frame here to see what was on my desktop. So we have our brand new UIKit project, and I don't want to show you how to embed a SwiftUI view that just says hello world, because it's not that interesting. So I will need to have a more complex SwiftUI view for it to be interesting. And the good thing is that in previous chapters we have implemented a few complex SwiftUI views. So I'm going to reuse one of these. I'm going to reuse actually the view we implemented in the chapter where we discovered the layout system. So the view that was similar to a product page on an e-commerce app. So I'm going to reuse that view. So if you want to get the code, you can get it. It's in the code of the chapter 2. I'm just going to copy paste because it's going to be faster for me. So I'm going to create a Swift file that I call content view, and I'm going to copy and paste what I had done in that chapter, so we can see our view with the scroll view. Remember, we had two scroll views inside each other, one horizontal and one vertical. And there were also a few resources, so I'm also going to add them. So there were 4 images in the asset catalog. So here they are. And there were also localized resources. So let me add a strings file, localizable, perfect. And I'm also going to just copy and paste from the project we did in chapter 2. All right. I'm just going to check on the preview that everything is working. Yes, it's working. It's the view we had implemented. The text is in French because I copied and pasted from the wrong project. That's because I have too many projects open. So I'm just going to use the right content just to make sure that there is a continuity between the chapters. Okay, so this time we have exactly what we did on chapter 2, and so we can see now how to embed this view into a SwiftUI. So how to embed this SwiftUI view in a UIKit app. Sorry for the small mistakes. That's when you see that for me in France it's currently 9 p.m. and after a day of work, it's the point where I start to get slightly tired. Okay, so good thing is that it's going to be actually quite simple to embed this. So first thing I need to do is to remove. You see, I have this storyboard right here, but I want to ignore it. And what I want to do is in which method do I want to do that? I guess this is in the app delegate. Yes, it's going to be in the app delegate. So here I'm going to get the window in which my app is going to run. I'm just checking like what is the right place to do it, because with the scene delegate, actually yes, I'm in the app delegate because like force of habits of being an iOS developer for some time, but actually for what I want to do, I want to go in the scene delegate because this is where you do it actually. So what I want to do is get the window that my app is running on, and on this window I want to access the root view controller. So in a UIKit app, this is where you would set a custom view controller as the root view controller of your app, and I want that root view controller to display my SwiftUI view, so my content view right here. And the way I do it is that first I import SwiftUI in my scene delegate. It feels a bit weird to import SwiftUI in a type that is so typical of UIKit. And then I use this type, which is called UI hosting controller. So it's a subclass of UI view controller, so we can use it anywhere a UI view controller is allowed. And as you can see, it creates a hosting. So sorry, I'm partly covering the text, but I'm going to read it out loud. It creates a hosting controller object that wraps the specified SwiftUI view. And so I'm going to pass as a SwiftUI view my content view. And if I didn't make any mistake, when I run my app, we should see, and we do see, my view being displayed. I'm just going to switch it into light mode because I've seen that sometimes the video compression is much better in light mode than it is in dark mode. So you can see my SwiftUI view is here. I can interact with everything that it has to offer. So the scroll view, both horizontal and vertical, and we are in a UIKit context. Actually, I can capture the view hierarchy to see what is exactly happening. So it needs to load a bit, but we can see that. Let me show you. I'm going to make it a bit more like that. Yes. So we have our UI window scene, and then the root view controller is our UI hosting controller that displays our SwiftUI view. And what was amazing is the fact that it only took this single line. So remember when I was telling you when you want to put a UIKit component inside the SwiftUI view hierarchy and just only do the basics of just displaying it, it takes only 10 or 11 lines. Here it took only one line, just one line. So it's even more impressive. It's kind of logical because SwiftUI is a language with a higher level of abstraction than UIKit. So basically, from a SwiftUI view, iOS can derive everything that is needed to translate it into the UIKit world, whereas when we have UIKit components, we need to do a bit of work in order to add the missing abstractions so SwiftUI can interact with our views. But here, it's basically all you need to do if you want to embed a SwiftUI view inside your existing UIKit app using UI hosting controller. So there is actually no equivalent of like UI hosting controller is a UI view controller. There is no equivalent of it for UI view in the general context, at least. And one of the reasons, and it's just like conjecture because I don't know what was the logic of the SwiftUI team, but it's because you can use a UI view controller like in most places, actually, because you can, as long as you are already in a UI view controller, you can create child views controller, and you've been able to do it since iOS 5, if I remember it correctly, so for a long time. So you shouldn't have any problem like using child view controllers. Like it's going to work perfectly well, and iOS and UIKit expect you to use child view controllers. So that's the first reason, and the second reason is that SwiftUI views, they are actually like more similar to view controllers than views in UIKit when you think about it. So it also makes sense that there is not a way to host a SwiftUI view as a UI view, unless in some specific context we're going to see just after. So as you can see, fairly easy. Actually, if you have an existing iOS app, it can also be a nice exercise to start and try to display a SwiftUI view somewhere in that app and see how it goes. And the reason why I'm telling you that is that you will notice fairly quickly that the issue is not actually displaying the SwiftUI view, because you just need to do that. And basically, like in your UIKit app, you're using UI view controller, so you just provide a UI hosting controller and that's it. It's going to work fine. What's going to be probably more complex is how you pass data between your existing UIKit architecture and this new SwiftUI view. This is where you need to do a little bit of thinking. This is also where I can not really provide you a one-size-fits-all solution, because every app has a different architecture, and so for every app it will be like the good solution will be slightly different. However, I can remind you that in this context right here, in this UIKit context, we can still use the mechanism that we saw before to pass data to our SwiftUI view. So for instance, we can pass data through the init of the SwiftUI view. We can also pass environment objects. So let me put it like that so that it's more clear, like, yes, it looks like better like that. So we can pass an environment. I want to show. I was just thinking, yes, it's better with this indentation level. So we can pass environment objects to the content view that we are about to give to the UI hosting controller. We can also pass environment values, so with the key path and the value. And most of the time, this should help you solve your trouble, because you can have observable objects in your UIKit app that you pass to your SwiftUI view. Or if there are specific methods that your SwiftUI view should call, you can also pass them through this second syntax, because remember, the values that we pass through the environment include closures. We can pass closures through the environment. We saw examples of it in previous chapters. And so, for instance, a typical example is that a button has been tapped in your SwiftUI view, and it needs to trigger a navigation at your UIKit level. Well, you just pass the closure that does that to the SwiftUI view, and in the SwiftUI view, you call that closure when the button is tapped. So really, using the environment, I'm trying to think about, I think like most cases where I had to pass data, either myself or my colleagues, using the environment, like solve the issue, or just passing the data as an argument of the view when it makes sense. So that's the basics of displaying a SwiftUI view in a UIKit context. Now, if you remember a few minutes ago, I told you that there is no equivalent of UI hosting controller for UI view except in specific context, and that's what we're going to see to finish this chapter. So what I'm about to show you was introduced in iOS 16, so you won't be able to use it unless you have iOS 16 or higher as your minimum target. But as the moment I'm recording, so I'm recording, we are on May the 4th, 2023. iOS 16 is only like a quarter away, basically. So if you start development on a new app today, it's actually very possible that iOS 16 will be your minimum supported version. And so there is a good chance that you might be able to use these new ways to embed SwiftUI views in UIKit apps. That's why I wanted to show it to you. So I'm going to need to set up a few things in my UIKit app. You'll see it will be fairly easy. I'm going to add a table view inside the view controller that's in my storyboard. So after what is like the 6th chapter talking about SwiftUI, working in a storyboard definitely like feels a bit like going back to the past. I need to add constraints, like the typical UIKit thing. Okay, so I have my table view. So now in the view controller, I'm gonna need to create an outlet. Let's see whether the control click is going to work. Yes, it worked. So I will have my table view. In my scene delegate, I'm going to comment this code out because I want the storyboard to be used this time to set up the first view controller of the app. And so in my view controller, I'm going to have some data. It's going to be static data just to save on time, because I don't want to show you like how to display data in particular. I want to show you how to use SwiftUI views inside UI table view cells. So just to keep it simple, we're going to display the integers from 0 all the way through 10, 10 being included. So I store them in an array like that. I'm also going to add a little number formatter so that we can display have a more interesting view than just displaying the number through string interpolation. So here this formatter will allow me to write a spelled out version of the number, so the number being written with letters. So like if it's 5, it will write FIVE, for instance. It might be that we will see it in French because part of my computer is set up in French. Then in view.did_load, I will need to set myself as set the view controller as the data source, and finally implement the data source. So in an extension, so extension of view controller UI table view data source. So first method, the number of rows in section is going to be the count of the array data. And also when you've become accustomed to building lists in SwiftUI, having to implement this data source also feels a bit antiquated. And then we have cell for row at index path. Let me format it a bit more so that it's just easier to see on the live stream, like that. So we create our cell. We just create a UI table view cell. I'm not going to deal with the reuse identifier because there won't be any scrolling anyway, so I'm simplifying that part. But of course, in a real app, you would want to deal with the reuse identifier. We also have the number that we're going to display. So for that, we take our array, and then we take the index path, the row of the index path, and we subscript the array with that. At the end of the method, we're going to return the cell, and the question is, how do we implement the cell so that it displays SwiftUI content? And this is when a new API added in iOS 16 comes into play. You can see that Xcode suggests it actually. So it's called content configuration, and I'm going to set to it a UI hosting configuration. So like this. You can see it's very similar to UI hosting controller, even in name, because we had UI hosting controller and here we have UI hosting configuration. The difference is that one has a root view, the other has a closure that gives some content. The reason for this is that most of the time we're going to define our content inline. When I say most of the time, maybe I'm getting a bit ahead of myself. Sometimes we will be using it inline. I'm checking whether I need to, yes, I need to import SwiftUI. That's what I wanted to check. So I need to import SwiftUI. And so inside the closure we pass to UI hosting configuration, we can actually implement a SwiftUI view. So for instance, I can define a VStack with a leading alignment. And for the content, I'm going to have a text that will say, okay, number, and then I'm going to interpolate the actual number. So I'm referring to this number right here. So the one that I got by subscripting the array with the row of the index path. And we can actually try to see what happens when I run this code. We can see that it worked as expected, meaning that I've been able to display SwiftUI views inside my UI table view cells. So I went for something very simple, but I can add more things in my VStack. For instance, I can add another text using my formatter. So I'm going to call string for number on my formatter. And since this returns an optional, I'm just going to say, okay, display the empty string if there is nothing. And you can see, yeah, they are spelled out in French. So if you ever wondered how the numbers from 0 to 10 are spelled out in French, you've got the answer. That's the bonus of this chapter. And you can see that with this new iOS 16 API, we are able to use SwiftUI content inside UI table view cells, and this also works with UI collection view cells. which is quite useful because most of the time now we kind of UI collection view has become much more of a default than UI table view. Also because it's very easy with a collection view to emulate the look and feel of a table view, but it's still available for both. And so if your app, if you're fortunate enough that your app supports iOS 16 as the minimum version, this is a great way to start using SwiftUI inside your app, because sales are usually views that are rather simple, and so it's a great way to start experimenting. First, because it will be easy to put in place, and secondly, because the view is quite simple. If for some reason it doesn't work out for you, it's not too hard to backpedal and use a UIKit UI view instead of a SwiftUI view for your cell. So that's quite a nice little addition. Once again, I'm sorry if you're not using iOS 16 as your minimum target, because you can't use it yet. I can tell you at work we are still using iOS 15 for now, so I haven't been able to use this hosting configuration yet in production, but I'm really looking forward to when iOS 16 is released and we stop supporting iOS 15, because then I will be able to give it a try. And I feel like it's just a really nice way, because there are a lot of iOS apps, including the one that I work on, where you have collection views that are like a central part of your app. In our case, the first page of the app that displays a lot of templates, a lot of tools, a lot of content that the user can interact with is implemented with a collection view. For now, maybe we'll redo it someday, but for now it's a collection view. And so there is always a time where you need to implement something new in that collection view, and being able to do it with SwiftUI will be great, because it will save us some time, and it can be especially great because sometimes we run experiments on that first page of the app, and when you run an experiment, there is always a chance that your code will actually be discarded because the experiment didn't convert. What you were trying to the optimization you were trying to make just doesn't work. Actually, more often than not, it doesn't work. So having when you know that your code is has maybe like 80% chances of not satisfying the need and going to the garbage, the less time you spend on it, the better it is. And so I see it also as a great way to enable like faster and easier experiments in existing iOS apps. And I'm checking, but I think I've told you everything I wanted to tell you. So I didn't lie when I said that it would probably be the shortest chapter in the course, because we are at not even an hour and 30. But I would say like this relatively like short time kind of goes to as the credit. Goes to the credit of the SwiftUI team, because it shows that they did a great job on making it like very easy to embed both SwiftUI views in UIKit apps, but also UIKit views in SwiftUI view hierarchies. I've showed you the basics for it. Now, if you want to try more complex use cases, you should know where to look. So if you want to do like a few exercises, like I said, like trying to embed popular UIKit components in SwiftUI is a good way to do it. And also trying to put some SwiftUI in your existing UIKit app can be really nice. If your app supports iOS 14 or higher as the minimum target, with what we've seen up until now in the course, normally you should have like all the knowledge needed to get started and try to implement a new feature of your app using SwiftUI rather than UIKit, even if your app is a UIKit app. And if actually, yes, you have this opportunity, I would really recommend that you try it out, because of course there will be there will be a learning curve, and there will be problems to be solved, but that's always the case when we try something new in computer science. But it seems that SwiftUI is picking up speed more and more each year. And even though UIKit is not going anywhere for the foreseeable future, SwiftUI is becoming more and more an important skill for an iOS developer. And so if you haven't had the opportunity to use SwiftUI in a production context up until now, I would really recommend to try and get that opportunity over the coming month or over the coming year, because that's my personal opinion. But I feel that we are really starting to be in the moment where SwiftUI is usable in production. It's usable in a way where it can help you deliver the same feature faster. And so, as a professional iOS developer, and by professional I mean someone that is paid by a company to solve problems using iOS skills, knowing about SwiftUI is becoming much more useful, and also much more needed. Like when I look back at the last year, I feel that every time I use SwiftUI, like 85 or 90% of the time, it ended up like allowing me to do something like faster, more efficiently. And if I hadn't known how to use like SwiftUI, I definitely would have probably regretted it. So I can only encourage you to try it out. So like the bottom line I'm trying to get across is, if you watch the course up until now, is great, and I thank you for it. But it's not enough. The next step is to actually get started and try to use it in your app. And even though this is not the final chapter of the course, I feel like it makes sense for me to deliver this speech now, because I feel we are at the moment in the course where we've covered all of the basics you need to start using SwiftUI. So you have the basics, now you just need to put them to good use, and I trust you that you will be able to do so. Since we're getting near to the end of that chapter, I told you at the beginning that it was probably the penultimate chapter of the course. So next week there should be what will probably be the last chapter of the course. And in this chapter, it will be a bit of miscellaneous content, but I would like to cover some of the UI components I haven't told you about, but which are still kind of important. Things like the lazy VStack and the lazy HStack, and how they relate to the regular VStack and HStacks. I might talk a bit about some of the API that were introduced with iOS 15. I'm thinking about the focus state API to be able to react to changes in a text field, to know when a text field has a focus or not. And I might also talk a bit about animations and transitions. So actually, I haven't found a name for that last chapter. So I need to focus on that, because the content is ready, but I just don't have the name, and calling it miscellaneous feels really not making enough fun effort. So I will think about the name. But most probably next week you will have the final chapter of this SwiftUI course. For today, I hope you enjoyed this chapter. For me, it's definitely one of the most satisfactory to deliver, because I feel we have reached a point where you are operational and you can start using SwiftUI by yourself, and you can start to gain value from using SwiftUI. So I hope that you also share this feeling. And I just have to say a big thank you to the people who made very good questions and remark in the chat during the live. I thank you, because it makes the live much more agreeable for me, but I also want to thank you on behalf of all the people watching the replay that will have probably found your comments and your questions very useful. I just have to say, enjoy the rest of your evening or of your day, depending of where you are in the world, and see you next time for the final chapter of the course. Bye bye.